Almost everyone has used an electromagnetic mobile clutch. The most common application is for an air conditioning compressor in cars and trucks. When an air conditioning system is turned on in a car, the electric clutch is activated, and the armature pulls against the rotating pulley driven by the rotating belt and turns on the air conditioning compressor. Electromagnetic clutches can be found in many applications that are transferring rotary motion from a gas or diesel engine to a pump, compressor, or other device requiring on-off rotary motion. Typical applications are under-hood air compressors, mobile hydraulic pumps, air conditioning compressors, high-pressure water pumps, vane pumps. The key components to the clutch are the armature rotor and field. Although these are two-piece clutches, the armature pulley assembly is actually 4 components pressed into one. These are the armature, which is connected to the hub via springs, rotor pulley, bearings, and field coil. Clutches come in 2 base types: shaft-mounted, where the rotor is mounted directly to the pump or compressor shaft, or snout-mounted, where the rotor mounts to an extended snout off the pump or compressor shaft. The advantage with the snout design is that the belt side load is taken up by the snout to the shaft, so the bearings in the pump or compressor can be sized smaller. For shaft mount clutches, the field can come in either a standard outside 4-bolt mount or an inside 3-bolt mount. Clutches operate electrically but transmit torque mechanically. When current is applied to the clutch becomes an electromagnet and produces magnetic lines of flux. Although specialty coils are available, approximately 80% of coils are 12 volts and 15% are 24 volts. In multiple pole clutches, the magnetic attraction points are multiplied by the number of flux paths created. Even though basic magnetic flux is created in the field coil, when it goes into the rotor design consists of a number of slots in the steel rotor. On the corresponding armature, similar slots are made, which forces the flux to travel in a north-south pattern, looping across the armature and rotor face. These multiple points of contact increase the torque in a smaller package, helping to reduce weight and size. The magnetized rotor and armature attract each other. The clutch momentarily slips on initial engagement. The torque is transmitted from the pulley rotor through the leaf springs and into the armature hub, driving the shaft of whatever is attached to the hub. When the clutch is fully engaged, there is no slippage, and the torque transfer is 100% efficient. Although some clutches use bidirectional dampened armatures, most mobile clutches use leaf springs to transmit the torque. The springs need to run in tension, not compression, so clutches are either built to run clockwise or counterclockwise. When the current voltage is removed from the clutch, the armature is pulled away and held in place by the leaf springs, creating a small air gap so there is no contact. In most mobile clutches, friction material is not used, and contact between the armature and the rotor is steel on steel. But in some special designs, friction material can be added to increase the contact area for high-speed engagements.